Good morning class. Today we discuss salt hydrolysis. Student, salt hydrolysis is defined as the process in which salt react with water to give back acid and base. They are the reverse of neutralization reaction. I repeat it again. Salt hydrolysis is the reaction in which salt react with water to give back acid and base. Salt hydrolysis are the reverse of neutralization reaction. In salt hydrolysis, salt react with water to give acid and base. Now let us discuss salt of different type. There are four different type of salts we obtain by the combination of strong acid and strong base. The salt of strong acid and strong base are generally neutral in nature. For example, NaCl, KCl, etc. The salt of strong acid and weak base are acidic in nature. Example is ammonium chloride. Salt of weak acid and strong base are generally basic in nature. Example CH3 COONA. The salt of weak base and weak acid are generally neutral or maybe acidic or maybe basic in nature according to situation. For example AlPO4 etc. Now let us discuss degree of hydrolysis. I repeat it again, degree of hydrolysis. The degree of hydrolysis is defined as the fraction of total salt which is hydrolyzed. The fraction of total salt which is hydrolyzed is said to be degree of hydrolysis. Here is one thing must be noted. The solution whose concentration is known is called standard solution. I repeat, the solution whose concentration is known as standard solution. Now let us discuss titration. Student, titration is the measurement of the volume of a solution of one reactant that is required to react completely with the measured amount of another reactant. Student, universal indicator is the mixture of number of indicators which show the color change by completing the reaction. Now let us discuss solubility product. Solubility product generally indicated by KSP. It's a solubility product. Solubility product is defined as the product of molar concentration of ions in a saturated solution. Each concentration raised to the power equal to the number of ions produced on dissociation of 1 mole of electrolyte. Suppose we have AXBY salt which on dissociation produce X of AY positive and Y of B X negative, then solubility product may be expressed as the product of AY positive raised to power X and B X negative raised to power Y. Here one thing must be noted. If the value of ionic product, that is the product of ions, if the value of ionic product greater than solubility product, then only precipitation occurs. I repeat it again. If the value of ionic product is greater than solubility product, then only precipitation take place. Now let us discuss common ion effect. Student, in the solution of weak electrolyte, if we are adding the strong electrolyte having same common ion, the degree of ionization of weak electrolyte is suppressed. This phenomena is called common ion effect. I repeat it again. In the solution of weak electrolyte, if we are adding strong electrolyte having same common ion, the degree of ionization of weak electrolyte is suppressed. This phenomena is called common ion effect. For example, in the solution of acetic acid which is weak electrolyte, when we add sodium acetate which is a strong electrolyte, the degree of ionization of acetic acid is suppressed due to the presence of common acetate ions. The phenomena called common ion effect. Now let us discuss the last topic of this chapter, buffer solution. The solution which resists change of its pH value by adding a small amount of acid or base or even by dilution is called buffer solution. I repeat, the solution which resists change of its pH value by adding a small amount of acid or base or even by dilution is called buffer solution. For example, blood is an example of buffer solution. We are eating variety of acidic and alkaline food, but the pH of blood is constant, approx 9.3. So blood is called buffer solution. Student, there are two types of buffer solutions. These are acidic buffer solution and basic buffer solution. The example of acidic buffer solution is the mixture of acetic acid along with sodium acetate. The mixture of acetic acid along with sodium acetate is an example of acidic buffer solution. But in the basic buffer solution, its example is ammonium hydroxide and ammonium chloride mixture is an example of basic buffer solution. Now let us discuss how we calculate pH of buffer solution. The pH of buffer solution can be calculated with the help of formula pH is equals to pKa plus log base 10 concentration of salt upon acid in case of acid, but in case of bases pH is calculated with the help of formula pKb, where pKb is the power of dissociation constant of base, log base 10 concentration of salt upon base. These two equations are said to be Henderson equation. These two equations are said to be Henderson equation. Here one thing must be noted, student. Degree of dissociation may be calculated with the help of formula number of moles dissociated by the total number of moles. Now